Before we can start with the first exercise, let me point out that I made all the exercises, so all the PDF files here, I made them myself, completely generated the PDF with my own tools. I also have developed the JavaScript, if JavaScript is embedded, and also the shellcode and the payload in some of the exercises is all developed by me, so it's completely controlled by me, and there are no real malware in the exercises. And you might have noticed that I use an older version of Adobe Reader. That is because it's an older version that is vulnerable to the util.printf bug that we will use in a later exercise. So let's start with the first exercise. Open the exercise, the PDF with Adobe Reader, and you will see that it is just one page with the text "Hello World." That's all it does. And this is just a simple PDF file, as simple as it can get, that I made, so that you can understand the internal workings of this PDF standard. So the exercise I made is just a plain text file. Normally, if you work with PDF files, if you produce PDF files or analyze malicious PDF files, they will be binary PDF files, but here in this first exercise, it's a plain ASCII PDF document that we can open with an editor like this one. Okay, so you can see it's just plain text. Now, what does a PDF reader do in the first instances when it opens a PDF file? Is first of all it checks for the presence of a header. This header here. This indicates that it is a PDF file and that the version of the PDF language that is used is 1.1. Another essential element that a PDF reader will check is if the file is terminated with an end of file indicator, %% end of file. So those two conditions have to be fulfilled before a PDF reader will recognize the file as a PDF document and try to parse it. So, okay, so once it has done that, it will look at a keyword, search for a keyword, start xref, which points to the beginning of the cross-reference table. So the cross-reference table starts at byte 644 in the PDF document. So let's go to this position, 644, and we arrive here, beginning at a cross-ref table. And the cross-ref table is followed by a trailer. If you see this construct in a PDF document, then you can know that this is a dictionary. A dictionary is identified by less than signs and closed by greater than signs. Dictionaries are built up composed of keys and value. Here we have a size key and a 7 as value, and here we have a root key and a reference. Now, a PDF document, the logical structure of a PDF document is a tree, so a data tree structure. And you know that a data tree structure has a root, the one node where all the other nodes are appended to, and this root is identified by the keyword root. Which object is the first node? It is object 1. 0 is the version of the object, and R indicates a reference. So we can read this as the root of our PDF document is object 1 version 0. Now, if we take a look in our cross-reference table, the first entry here is default entry, and then we have entries for each object. So the first object, object 1, that's this entry, is located at position 12 into the PDF document. So let's go to location 12 by 12, and here we have our first object, which is the root of our tree. So an object in a PDF document has an index 1 here, object 1, a version, which is by default always 0, and then keywords that delimit the object, obj, followed by, terminated by end obj. We see that our root object here is a dictionary. Its type is a catalog, and it points to a set of pages, which is another object, object 3, version 0 we are referencing. So now I could go back to the crossref table to find the position of object 3, but because this is here a really small PDF document that I've produced with a layout so that it's easy to read, we can easily find object 3 here. So object 3 is the set of pages. You can see that the type is pages. How many pages? 1 page in this document. And we, in kits here, we reference all the pages that make up the document. So our page is object 4. Let's go to object 4. It's here. We have a type page, a media box that defines the size of the page, resources like fonts. But the most important part for us is the content. The content is referenced in object 5. So let's go to object 5. Here is object 5. And you can see that we have the text hello world here that is displayed on the page. Now, again, this is because I produced a pure ASCII text file, a PDF file. If you open normal PDF files, you will not be able to find the text. We will see that in a later exercise. Notice also that object 5 is a stream object. A stream object contains a data stream. This is the data stream, and the data stream is delimited by keyword stream and endstream. Usually the size of the data stream is also included. It's 43 bytes here. So this is our PDF document. It's not that difficult to read once you know how it is produced. So the text hello world we see here is printed here. These are all commands. I'm not going to explain them into detail, but if you're interested, this is the start of the command. This is the end of the commands. The commands are also listed here in reverse Polish notation, so that's to say that the arguments come first and then you have the command. Like here, we have a command that says that we use font 1, size 24. Here we have a command to position our text at location x100, y700, and then we have the string hello world that is printed to the screen. Strings in PDF documents are always enclosed by parentheses. So this first exercise is a really simple PDF file. You don't actually need my tools to analyze it. You can just do it with a text editor like we did. But still I will show how you use my tools to analyze this PDF document. So the first tool you would use is PDF ID, and PDF ID is actually a tool that you use to classify, to triage PDF documents, so that you get an ID of what is in the PDF document and if it is interesting to analyze, so that it can potentially contain malware, be malicious, or that it is just a benign PDF document. So when you run PDF ID on the first exercise, first of all, it identifies it as a PDF document and presents you with a header, and then it will list all different types of objects and keywords that it has counted, and here you can see the count. So we have number of OBJ keywords is 6, and OBJ is also 6, stream 1, and so on. So you can see that the keywords and the objects that I showed you in the text editor are just counted here by PDF ID. And this is just a plain simple PDF document. We have nothing special like JavaScript or encryption or anything. We just have one page and the usual objects you expect to find in a normal PDF file: objects, streams, references, and the trailer. So that is PDF ID. So based on this output, I would not further analyze the PDF document with PDF parser, but here let me just show you how you would do that. So you launch PDF parser on the exercise, PDF exercise 1, and here you have the output. So it has listed and parsed different objects, like object 6 here, and so on. If you want to parse a specific object, you can just specify that with option -O. -O for object. We want to see object 5. Remember, object 5 is the content of our page, and we select our first exercise, and then here you have object 5 that is parsed by the PDF parser.